Hi, my name is Lucas Clatterball. I will be presenting my evidence-based project on dark matter and what it is, the three main observation points that we have for it, and as well as a few models and assessment, or my assessment of it. So essentially, what it is, dark matter is we predict to be a particle or particles in universes and galaxies that have a gravitational force, but however do not interact with light or cannot be seen in any way that we have so far. So the first observation that we have to prove dark matter is rotational curves in spiral galaxies. So essentially, when you have a system in rotation with stars or planets, and there's a lot of gravity. The objects on the outside of the field should be traveling slower, as it does in solar systems like our own. However, in spiral galaxies, this is not the case. They're actually speeding up, which means the mass is not centered in the center of the galaxy. Another point of evidence that we have for dark matter is the hot gas in cluster and gas clusters, and essentially, when you calculate all of the mass that is in a cluster of gas, the amount of gravity there is much higher than it should be based on just the gas, and we can tell that based off the X-ray waves that come from the hot parts of the gas cluster, the most massive parts. Another point that we have, another observation that we have is gravitational lensing. That uses the same basic idea of the calculations that the dark matter is too much, the mass of that area is too high to calculate for all the mass that we can observe inside of it. So we will have gravitational lensing and distortion of light where there shouldn't be distortion of light. And essentially that is because of the extra mass created by dark matter. And I have a few points here. Gravitational lensing. So basically, when you have this light, it should theoretically travel straight through with a certain amount of mass. But when you account for dark matter, it begins to distort, which is why we'll see it multiple times rather than just the once. And then we also have these large-scale structures in our universe where there seems to be consistent density. Also, we predict also created by dark matter, which creates things such as the Sloan Great Wall. And because of that, we believe that dark matter is consistent throughout universe's time. So whether or not there is mass there or not, that density will stay. So my assessment of it, I believe that it's very possible for there to be dark matter. However, there's no real I guess with my thing with dark matter is there's no real premise to it. There's no real like fight to it, like, as if it's not claiming to be anything. So I have a hard time to disagree with what dark matter is. So I believe that given the evidence and given these models, that it makes sense for dark matter to exist in our universe, whether it be observable or not. Thank you.